So let's try to get a little further. I don't know if we'll completely finish today or not, but we'll get a little bit further with this Pythagorean theorem. So let's review it briefly. You can only use Pythagorean theorem with what kind of triangles? A right triangle, that's correct. All right, so let's draw a right triangle just so we remember. We didn't do a whole lot yesterday, so the review should be quick. All right, so you can only use Pythagorean theorem on right triangles. Now, there's something later on that you're going to learn, maybe in Algebra 2, depending on how fast you go, maybe towards the very end of Algebra 2. And it's called the law of sines, law of cosines. And you can use that with non-right triangles, all right? But for right now, we're just going to deal with triangles, and you can use the Pythagorean theorem to find the missing sides and stuff. All right, so let's see. We'll call one leg A, we'll call one leg B, and the hypotenuse is always C. How do we know that that's the hypotenuse?
It's across from the right angle.
Right, it's opposite or across from the right angle. All right, so that's always the hypotenuse. The hypotenuse on any right triangle is also going to be the what? The biggest, the smallest, the medium, which one? The biggest side, okay? I don't know, have we talked about this? I think we talked about this. Didn't we say when you have a triangle? No, I don't know if we did this or not. We will eventually at some point. If you have, watch, if this is 30 and this is 60 and this is 90 degrees, I can tell you which one is the biggest side, the longest side. I can tell you the shortest side. I can tell you the medium side. Did we do that? Yeah, we did. That's what I thought, okay? Again, I teach 2 other geometry classes. I can't remember what I said in each of them. So this is the biggest angle, right? So what's the biggest side always going to be? It's always going to be C, okay? Because it's opposite the biggest angle. You follow me? So, and what do we call it? I said it once. What do we call this? High what? Hypotenuse, right? So the hypotenuse is always going to be the largest side of a right triangle, right? And then you can look at the other 2 sides depending on what the angles are. You can tell which one's the smaller one, which one's the bigger one. The bigger leg, I should say. Everybody with me on that? All right, and there's a relationship between A, B, and C. So remember, Pythagorean theorem is easy as what? A, B, C. So what is it? A what? Squared plus B squared equals C squared. Yeah, it's a really simple formula. Out of all the formulas that you memorize in math, this may be the easiest one, just because it goes A, B, C, right? Now, you do have to remember to square them and add them up, okay? But it's pretty simple to remember. Remember the last thing that we did yesterday? I said this side was 3 and this side was 4. And we did the Pythagorean theorem, right, to find the third side. Let's do it super quick. So it's 3 squared plus 4 squared equals what? C squared. Well, we don't know it's 5 just yet, okay? Because you saw it yesterday, you know, but let's pretend we don't know what that side is. So it's C though, right? So let's do it. So this is 9 plus 16, which is 25. It's not 25 squared. 25 equals what? C squared. How do I get C by itself? I get a square root it, that's right. Square root, what's the square root of 25? It's 5. So, yes, it is 5, isn't it? So that side is 5. This is kind of a special triangle. It's called a 3, 4, 5 triangle. You see it a lot. In, what are you guys, 9th grade? In 2 years, I think you'll take, maybe, did they do this in 10th grade? Did they take the PSAT in 10th grade? I think you'd take the PSAT in 10th grade. So anyway, you'll have a lot of geometry on the PSAT. And one of the things that's going to be very helpful, instead of going through all this, now that didn't take that long, did it? But if I just saw a 3 and a 4, I already know, if it's a right triangle, what the hypotenuse is going to be, don't I? I know it's going to be 5. So do I have to go through this? Now, as you know from earlier today, I'm a stickler on showing your work, like on your homeworks and stuff like that. But on an achievement test or a college entry test or something like that, you don't have to show your work. They just want to know the answers, that you know the answers, okay? So really, do you have to do all this work on one of these like achievement test kind of things in order to get the answer? Not on this one. You can just look at it and say 3, 4, 5. What if we had this? There's a lot of stuff here. Let me get rid of some of this. What if, let's get rid of this and this, and we'll get rid of these. It really doesn't matter, because really these, those angles that I have right there would not be correct with 3, 4, and 5. That's a later topic. It's not a geometry. It might be a geometry thing. We might actually get to law of sines, law of cosines at the very, very end of geometry. We'll see how long we have left and if I want to skip to it. I have done that in geometry before, gone to the law of sines, law of cosines, which is a pretty good and useful thing to know if you're trying to find missing sides and missing angles of triangles, not just right triangles. All right, enough of that. What if I said that this was 5 and this was 3, and I asked you to find that right there? Do you have to go through the math? No? Okay, what would it be? It'd be 4, right, because 3, 4, and 5. What if I did this? What if I said this was 4? Would this be 5? No, it wouldn't, because it's got to go 3, 4, 5. The hypotenuse has to be the longest side. So right now, 4 is the longest side. Let's just do this just for fun. I wasn't even thinking about doing this problem, but let's just do it for fun. How would I solve for x? I'll tell you right now, it's not going to be pretty, but it's okay. It's still a number. It still works. What would I do? A squared plus b squared. So what do I have?
Oh, I was asking something
Go
like
ahead.
to be on the test.
No, this
Or
is just me
having fun with it.
having fun with it. That's right. All right. So a squared plus b squared. Does it matter that that's a? Does that have to be a every single time? No. So if that's a variable, I'd rather have that to be my a. So instead of calling it a, we'll just call it what? X. And then what do we do to it? Squared. Plus what? 3 squared. And what should that equal? 4 squared. So what I have to do is figure out what x is. Well, let's do the math. 3 squared is? 4 squared is? 16. Subtract 9 this time, right? And then x squared equals, what's that? 7? And then now, what do we do? Square root, and just keep your answer just like that. That's what that length is. It's the square root of 7. Square root of 7 is like 2 point something. Is that right?
Something like that.
Yeah. 4 because 3 would be 9. Yeah, it's like 2 point something. It's not really drawn to scale here. Square root of 7. Yep, 2.6. Okay, it's about 2.6. Keeps on going. The decimal keeps on going forever. By the way, I'm just thinking of a bunch of stuff just off the top of my head. If the decimal keeps on going forever and ever, we give that a name, that kind of number a name. Anybody remember that starts with an I, R? Irrational. Very good. So you've heard that before, right? I think there's 2 R's in it. Is that right? I'm pretty sure. Yep. It's called an irrational number. Okay, irrational number. What's a number that we use? Actually, we're going to use it later on in this chapter. When you talk about circles, have we talked about circles at all in here? Okay. Pi. Pi is also an irrational number. We always know pi is what? 3.14. But does it stop right there? No, it keeps on going. I only have it memorized 159. There's really no reason to memorize it any further than that. But it goes ... Why do I put ... Yeah, it keeps on going forever. Okay, it doesn't repeat a pattern though. That's the thing about an irrational number. Like 1/3. What's 1/3 approximately equal to? Right, it's 0.33333, and it keeps on going. It repeats that pattern. Agreed? All right, it keeps on going forever. That's not an irrational number. It's rational because 1/3 is a ratio. It's a number to another number. That's where the word, see the word ratio right there? That's a ratio. Agreed? Anytime you can make a fraction, it'll turn into a decimal, but it either stops, the decimal will stop, like a half. What's a half? It's 0.5. That stops, doesn't it? It doesn't repeat. That's a what? Rational number. You follow me on that? This is irrational. The square root of 7 is an irrational number. Any square root that doesn't come out even is an irrational number, like the square root of 2 is an irrational number, the square root of 3. What's the square root of 4? Is the square root of 4 irrational? No, because what's the square root of 4? It's 2. And does that keep on going? No. All right? So this keeps on going, but it doesn't repeat any kind of a pattern. There may be a time in there somewhere where you might have like a 2 and a 2 next to each other, but then after that it just, again, goes kind of like randomly. All right? So it's not really random, but to us it looks like they're just a bunch of random numbers. Okay? All right, enough of that. I figured since I was there, we might as well talk about it. Let's do that triangle again. Let's do this. I'm going to copy that. I'm going to bring it down here. Let's paste it. And what if I did this? All right. Keep that 3, 4, 5 triangle in mind. In fact, a lot of times you'll see it written like this: 3, 4, 5 triangle. This is a special triangle, and it's called a Pythagorean triple. All right. I'll just shorten Pythagorean triple. Right? Because it means that all three of these numbers come out to whole numbers. There's no square root of 7 in there or something like that. There's no decimal. There's no fraction. Okay, they're just nice whole numbers. That's when you have a Pythagorean triple. Let's find some offshoots of a 3, 4, 5 triangle Pythagorean triple. So, for instance, what if I said this was 6 and this was 8? It would be 10. Very good. Right? Because what did we just do to all the sides? We didn't add 2. Okay, we doubled it, right, because I didn't add 2 to 3. I doubled 3, and I doubled 4. So what am I going to do to 5? I'm going to double 5. So 6, 8, 10 would also, whoops, got ahead of myself. 6, 8, 10 would also be a Pythagorean triple, but really it's the same triple as that, isn't it? Okay? I could have a what? A 9, 12, what? 15 triangle. But again, that all goes, these are just kind of like, I don't know, subsets, probably not the best word, but they're kind of offshoots of the 3, 4, 5. Make sense? So if you had something like this, and they asked you to solve for x, you should be able to do it with minimal effort. Do you have to go through that whole Pythagorean theorem to get that? You should not have to, all right? Because you're like, oh, 6 and 10, well, 2 goes into 6 and 2 goes into 10, right? So 2 goes into 6 how many times? 3 times. Into this 5 times. Oh, there's a 3, what? 4, 5 triangle. But it's not 4, it's what? It's 4 times 2, which is 8. You see that? All right, and it's like a little, what do they say nowadays? A cheat code, right? Right? People say that all the time for everything now. Okay, that's your cheat code. All right, is knowing that it's a 3, 4, 5 triangle. Well, there's other Pythagorean triples that are nice to know. All right, and I'm just going to give them to you. 5, 12, 13. That's another Pythagorean triple. If you don't believe me, this is the only one that will do this to. But if you don't believe me, try it out. What would you do to see if that was true? You take 5, what? Squared plus 12 squared, and that should equal what? 13 squared, if this is truly a Pythagorean triple. Let's see if it does. What's that? 25. That's 144. What's 13 squared? Any idea? I know that one. It's 169. All right? And if you add these, what's 25 and 144? That's 169. So does 169 equal 169? Yes, of course it does. All right? So that does work, doesn't it? All right? So there's a handful of these Pythagorean triples. I mean, there's a whole bunch of them. In fact, there's probably an unlimited number, an infinite number of Pythagorean triples. But you'd have to get super big, crazy numbers. But the numbers that we deal with most of the time, there's just basically a handful of them. All right, so let me give you some more. So what do we have so far? Let's make a list. So we have 3, 4, 5. What was the other one? 5, 12, 13. Do you have to memorize these? No. This is for your benefit. This is so that when you look at it on a homework problem, if I did this, this is a situation, now listen to me, this is a situation where you don't really have to show your work, okay? Because you can just look at it and write down an answer. But there's a lot of times, though, where you have to show some work. On this one, you don't, because you should have some of them, memorized. So 5, what, 13? You're like, oh yeah, we talked about that in class. Pythagorean triples, 5, 12, 13. All right? And then you can just write that down, and that's your answer. All right? I'm perfectly fine with that. All right? If you can memorize things and put it down. All right? Here's a couple more. I have to look myself because I don't really remember a lot of these. But it is helpful, especially when you take like your SAT I really haven't seen many more than these, but these are your common, we'll call them, your most common Pythagorean triples. So again, why is this useful? It's useful because if you have some of these memorized, then it just makes things go faster and quicker. So you're taking the SAT, right? You're looking at a problem and it'll say solve for X. And they'll say this is 24 and this is 25, all right? And you're looking through it. You could say, oh, it's a right triangle. Oh, this is Pythagorean theorem. So I could go x squared plus 24 squared equals 25 squared. And then you'd have to go through all that, wouldn't you? All right, you have to do all that work and you come up with whatever x is. But if you have some of these memorized, what is 24 just by looking at this list? Or sorry, what's x looking at this list right here? What is it? It's just 7, that's right. So that is 7. Isn't it a lot easier just memorizing it and knowing and writing down 7? Then you go to the next problem. Because your PSATs and your SATs and all that kind of stuff, they're timed tests. You know how when you take your achievement test in school, you know, you do the bubbles and all that kind of stuff. Most of the time you finish real early, don't you? I remember when I took them, I would bring a book or I'd bring something to read after I finished. Because I'd finish really early, you'd have like 10 more minutes left over, and so I sit there and read a book. On the PSATs, it's not like that. I mean, you're going to wish you had way more time, right? Because it's a lot harder, all right? The PSAT and the SAT. PSAT is a pre-SAT, all right? And usually you take that in high school just to kind of gauge yourself to see what you could possibly get when you actually do take the SAT that colleges look at, okay? In fact, from what I've been seeing in the news, a lot of colleges are not requiring SAT scores anymore, all right? It's because the whole, I don't know. I don't even know why. It's ridiculous. They just want it to be fair to everybody and everything. But, I mean, there's times where you got to achieve, you know? There's times when you have to achieve stuff, you know? And you got to, anyway, I won't get into that. It's a whole political thing. But, well, why my screen didn't do it up there? But I don't think, is this plugged in? Hold on. Time out for a second. Oh, no wonder. I was wondering why it was acting weird. Where's my... Because it's not plugged in, and there's the cord. There it is. I was wondering why the program seemed to be dragging a little bit, and my screen turned dark because the battery's going dead. And let me do this. You can't see any of this on that screen up there. Oh, here we go. But on my monitor, it went all kind of dark on me. All right, there we go. Now it's plugged in. What else do we want to do? Let's do one more thing. Let's do an example, maybe 2 examples. I think we can do this. I think I mentioned this yesterday. I said we're going to do some math that you may not have done before. So I'm going to teach a little bit of algebra here. And I will not, I'll tell you right now, I will not have this on a quiz or a test. Oops. But I think it's good for us, especially as honor students. I know you hate hearing that all the time, but it's okay. You're an honor student for a reason, right? Because you go above and beyond what's expected. That's what it should be. Now, here's where it's a little different. Okay? So it's going to be a little bit weird. I'm not going to expect you to be able to do this. I'm just going to show you how to do it. Because I just don't have time. Let's put that one on hold for a second. Let's do the next one. I'm going to copy that one. What's that? Well, we don't know. We don't know exactly. You are right, though. That's good observation. But there's a way to do it more precisely, I guess. More algebraically. But you are right, it is. It's an 8, 15, 17. So it's one of our, but it's not always going to work out that way. If this wasn't plus 7, it might be something else. You might get some weird answers. This one does come out even, and it does come out to 8, 15, and 17. But we need to be able to show that it does. Let's do example 2 first, because it's a little quicker, and then if we have time, we'll go back to that one. It says, find the area of an equilateral triangle. Do you remember talking about equilateral triangles? What does that mean? All the sides are equal, which also makes the what? The angles equal to each other as well, okay? All right, so here's an equilateral triangle, and it says find the area of it if one of the sides is 8. So that side right there is 8, and I want to find the area of that. And you're like, well, wait a minute. How in the world am I going to find the area of it if I only know one side? Well, they're all equal. Exactly right. So that's an 8, and that's an 8. That's good because it's an equilateral triangle. So I have a base. That's good. What am I missing? A height. So where is the height? Well, it's from the top. Don't say straight down. What is it? Perpendicular. So now I have a what kind of triangle? Right triangle. Okay. I don't know if you remember, but what does this do? This actually splits it up into 2 congruent triangles. So that means that if it splits it into 2 congruent triangles, this little side right here and this little part right here are equal to each other. So what is this little part then? It's 4. Okay. Now, check out what we have. We have a triangle. We have a right triangle. We don't know the height. This is the, yeah, this is, hold on a sec. Yeah. Hold on, I'm trying to think of something. Yeah, let's just do it like this. Okay, so now we have a right triangle. Do you see that? You can use either one of them because they're both exactly the same. Let's just take a look at that triangle right there. So what is the area of a triangle? It's 1/2 what? The base times the height. Okay. Do I know the base of this right triangle? Yeah, it's 4, isn't it? So it's 1/2 times what? Times 4? Actually, I'm sorry. You got to find the height. That's what I was worried about. Okay, so you got to find the height first. Okay, so we got to find the height to be able to find the area. So we have a right triangle. So what do we do to find the height? Use the what? Pythagorean theorem. So let's set it up. So we'll call that our A squared. What would our B be? 4. It'd be 4, right? And then we square that. Equals the hypotenuse squared. What's the hypotenuse? 8 squared. So let's do this real quick. This is plus what? 16. That's 64. And then subtract a 16. Subtract a 16. What's that? 50, 40, 48. Is that right? All right. And then so what do we do here? Take the square root. Take the square root. Now let me show you something real quick. We got like 2 minutes left. So let me show you what we need to do here. I think I might have shown you this long time ago. Okay. Again, hate to keep dwelling on this. This is something that you probably should have learned in Algebra 1. You'll definitely learn in Algebra 2 for a fact. Let's not pack up. Let's do this. So what we're going to do is we want to break this up into something times something, right, that equals 48. So what do you think? What times what equals 48?
6 times 8.
Okay, 6 times 8. All right, I'll tell you what. Let's do this over here. Let's use 6 times 8. What I want to do, can you take the square root of 6? Can you take the square root of 8? Not really. So let's take 6 and break that down as much as you can. What's that going to be? 2 times 3. What's this going to be? 4 times 2, correct? Now check this out. I got a 4, which I can take the square root of. Agree? Okay, I got another 4. Where's the other 4? The 2 times 2. So really, 2 times 2 is 4 times 4 is what? Can I take the square root of 16? Yeah, so this is what? 16 times what? 3. Why did I pick 16? Because I know I can take the square root of 16, okay? you remember doing this? So I can break this down. We have a rule in algebra. If you learn this in Algebra 1, you learn that you can split this up into 2 separate square roots. Okay? And what's the square root of 16? 4. Can I do anything with the square root of 3? No. So technically, that's our height. That's the way math teachers want you to write your answer. They always want you to write it simplified, not like this, not as a decimal. Okay? Don't put it into a calculator to get a decimal. So that's my height. So now, how do I find the area of the whole entire triangle? Not just this triangle, but the whole entire triangle. It's 1/2 the base. What's the base of the whole entire triangle? It's 8 times the height. What's the height? 4 times the square root of 3. And now you just work it out. Let's do it. What's 1/2 of 8? That's 4. 4 times 4 is 16, square root of 3. And then I think they said this was in centimeters. So how do we write this? Centimeters what? Squared. So that is the exact way to write that. That example 1 that I wrote down earlier, maybe we'll do that after the quiz tomorrow, because it's got some algebra in there I can almost guarantee that you have not done before. But I think it'll be good for you to see it and go from there. You know that Eddie Wu guy that I just showed you?
Yeah.
The very first video? That's basically what he was doing. He was doing what I'm going to show you next, okay? So there is homework with that. I don't know what it is. What is it? I'll tell you what. Let's just do the part A. I didn't give you anything yesterday, did I? So let's just do part A, which is 1 to 10, 13 to 19. 1 to 10, 13 to 19.